Hello students, my name is Charu. Welcome to the TEQIP GATE classes, an initiative by the TEQIP faculties. So in the last lecture we have studied the different page replacement algorithms in operating system. Hope the topic is clear to you. Next topic is file system. So the next topic is file system in operating system. So first you need to understand the basics of the file system. What is file? File is a collection of related information that is recorded on the secondary storage. Okay, and there is different types of files will be there: doc, exe, jpg, and associated attributes with each of the type of file. And there can be different operations. Operations can be different types of operations will be there. Either you can search a file, create a file, okay, delete a file. There may be different operations associated with the file. Next we have the file directory. What is file directories? It is a collection of files. So it is a collection of files. It contains the information. It also contains the information about the files, including their attributes, location, information about the files and their attributes, location. So this is the following is the information maintained by the directory. What is the information? Name, type of the file, address, current length, maximum length, date when it was last accessed, date when it was last updated, owner ID, protection information. Everything is there in the file directory, right? So next one is the why do we maintain these directories? For a better efficiency, for grouping, for naming, right? So for the better efficiency, for the grouping, or for the naming. So what do you mean by efficiency? File can be located more quickly, right? File can be located more quickly, right? Next one is grouping. Grouping means logically grouping can be done, right? Logically grouping can be done. Next one is naming. Why do we name? So it is easy to identify for the user. It is easy to identify, right, for the users. So that's why we maintain the name. Next one is we have different types of directories. First type of directory we have is single level directory, two level directory. Then we have tree structure directories. These are the different types of directories will be there. First we will understand what do you mean by this single level directory. So for all users, single directory is maintained, right? Suppose this is the directory, okay, and this is containing the file. Each one is containing the file. Only one directory will be there for all the users. User A is accessing file B, C, D, E, so on. Okay, but here we have some disadvantage. What? That users can't have same name for two files. They can't have same name for the two files. So there is naming problem. There is naming problem. Okay. Second one is grouping. Users can't group according to users cannot group according to the requirement. Okay, according to their requirement, they can't group. That is the big disadvantage of this single level directory. Next, we have type of directory is the two level directory. Here we have two level directory. Okay, so what we have here, we have one master file directory. Okay, first level of directory is maintained, then second level of directory is maintained. So suppose we have 4 users here, user 1, user 2, user 3 and user 4. So the different directories are maintained for the different users. Like for user 1, this directory is maintained, for user 2, this one, and so on like this. This we call as master file directory, this we call as user file directory. And here we have the data in the files. Okay, so here the directory is maintained level wise. We have 2 levels here. So here, due to 2 levels, there is path name for every file. If you want to locate the file, you can easily locate it, right? And we can have here, we can have here same name file for different uses. Okay, see here I have file name as and say B here, and here same name I have given here also B. So you can have the same name file for different users because path is different now. You can have the same file. Next one is tree structure directory. Here the directory is maintained in the form of tree, right? And I forgot to mention here the searching will be fast. Searching will be fast. So here in this tree structure directory, here the directory is maintained in the form of tree like a structure, right? So directory is kept in the form of tree. Searching will be efficient, right? But we can't share files here. Can't share files here. Okay. So what we have here, this is the one directory that is linked to the D2 directory, that is here D3, D4, then D5. We have multiple directories here. So it is connected to this directory, then further this is connected to another directory, and then they have files in the form of data. Okay, so just we store the directory in the form of tree. So we have here, we have absolute path name, right? We have absolute path name here. Next one is, there is different types of file allocation methods. We have different types of file allocation methods, so that are used to allocate disk space. Okay, so later on we'll understand what do you understand by this disk and what is the structure of disk. Okay, so it is used to allocate disk space. The selection of the best method for the file allocation should be done as it will directly affect the system performance and efficiency. If you want to increase the performance and efficiency, you have to select the best file allocation method. Okay, with the help of the file allocation methods, we can better utilize the disk and also files can be accessed easily. There are different types of file allocation method is there. The first one is contiguous allocation method, next one is linked allocation list allocation method, then is indexed allocation method. So contiguous allocation method is the method where we allocate the block in such a manner so that in the hard disk all the blocks get the contiguous physical block. So what we have here, suppose I am having the hard disk. I'm having the hard disk and I have different blocks 0, 1, 2, 3, 4, 5, 6, 7. This is the hard disk. Alright. And we have different blocks in the hard disk. But that block are having contiguous physical blocks will be there. Means we should allocate the space like this, that they should be in contiguous manner. And the directory is maintained. Okay. So we have file name followed by starting block of that file name indicating start, then length, then we have allocated blocks. Okay. Suppose file name is ABC. Suppose ABC is the file name, abc.text. Okay. So 0 is the start and length is the 3 and blocks allocated should be 0, 1, 2. Okay, 3. I have to allocate the block length of 3. Okay, suppose it is first block. Okay, 0, 1, 2. I can't allocate like 0, 4, 8. I have to allocate the block in the contiguous manner. After 0, 1 should be there. After 1, 2 should be there. Like in the contiguous manner, I have to allocate the block for the particular file. But there should be space in the hard disk. Okay. So there should be a condition that there should be empty space in the contiguous manner. Okay, that's why contiguous allocation method. So abc.text, if I want to store, I will store in the blocks 0, 1, 2 like this in the contiguous manner. Suppose next file is .jpg. So it can be starting from 3 because I have seen that 3, 4, 5, 6, 7, 8 blocks are free. So I can give it the starting block as 3. So let me take the length as 2. So allocated blocks will be 3 and 4. It should be in contiguous manner. So this block is allocated and this block is allocated to the file name D. Okay. So like this you can allocate the different blocks to the different files and in the hard disk, but that should be in contiguous manner. So there are different advantages and disadvantages. Advantage is simple, it is easy to implement, possible sequential access, direct access, fast is method is there, but it is having disadvantage that sometimes disk can be fragmented or it is difficult to increase the size of the file. It is difficult to increase the size of file due to contiguous allocation. Okay, so this is the major disadvantage of this method. Okay, this is the major disadvantage of this method, that we are not able to increase the size due to the contiguous allocation. Okay, second one is linked list allocation method. Okay, linked list allocation method. See this method. So here in the linked list allocation method, here the disk blocks are not assigned to a specific file in the contiguous order on the hard disk. The directory entry consists of a pointer for starting the file block and for the ending of the file block. Okay. And each disk block that is allocated or assigned to a file consists of a pointer. And the pointer points to the next block of the disk that is allocated to the same file. Okay. Let's see with the help of example how this method is being implemented. Suppose I am having the hard disk, right? And same, I'm having the blocks, but you can't have the restriction here that you have to allocate the blocks in the contiguous manner. Okay, so what is happening here? The file name, then we have start, then we have end. Okay, this is the directory. So suppose I'm having the file name as ABC and starting is from 4 and ending is at 8. Okay, so what is happening here? It is given that the file name is starting at 4 and ending at 8. So it will be containing the, suppose I'm starting with 8 and then I'm reaching to 3, then I'm sorry, I have to start from 4 here because starting point is 4. So let me direct. Okay. So first I'm starting from 4, I'm pointing towards 3. First data will be stored in here, then at 3, then a part is stored at suppose 7, and then at 8. Okay, so it will end at 8. So it will be containing blocks like 4, 3, 7, 8. So you can see that it is not in the contiguous manner. Okay, a pointer is pointing to the next block, then next block, then the ending block. Okay, so there is a starting block and there is a ending block. I hope this is clear to you. The linked list allocation method. So here no external fragmentation is there since the size is not defined. We can adjust according to the requirement, and moreover the space is not the allocation is not in the contiguous manner. Okay, here we can increase the size of file as there is no contiguous allocation. Okay, so there is no contiguous allocation. Next one is indexed. Next one is indexed allocation method. So in the index allocation method, there is additional block, there is additional block, and that block is called as index block is maintained. Okay, so we maintain the index block, and for each file there is different index block, and in the index block I entry holds the disk address of the ith file. Okay, so suppose I have the hard disk, and here I have different blocks. In the hard disk, right? So I have to maintain here the file name, and second column is reserved for the indexed block. Okay, suppose A is the file name and index block is 11. If I have 9, 11. So here also this index block will contain all the information that where the data of file is stored in the hard disk. Okay, it pointing towards like it is stored in 8, then 5, then 2, then 9, then 10. So it will indicate first data is stored in 8, 5, 2, 9, 10. Okay, and this 11 is the index blocks. 11 is the index block. So it is pointing, it is keeping the address of different blocks that where the data is stored. That your information is stored respect to the file A in 8, 5, 2, 9, 10, and all the information is kept in the index blocks. Means the address of the blocks is stored in the index block. Okay, so it supports the direct access, supports the direct access. Next we have the architecture of the magnetic disk. Architecture of the magnetic disk. This is the magnetic disk. Okay, so a magnetic disk has many platters, and each platter is divided into tracks. Further, each track is divided into the sectors. See this figure. So this one is the platter. This 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 surface is the platter. Okay. Next, the platter is divided into the tracks. These circles are present over the platter that are indicating the tracks. Okay, this is the circles that are indicated over the platter, that is called as track. Okay, and further the track is divided into these sectors. ये जो sectors में divided हैं, multiple sectors में, that is track is divided into number of sectors. You can see the CD also. CD, there is circular circles are there. Circles are there on the CD that are indicating the tracks. Okay, and the surface is called as platter. Okay, and this form the cylinder, right? When you see the multiple platters are organized, how they are organized? They are organized in the form of cylinder, one above the other, one above the other. Okay, and the tracks will be divided into sectors. Okay, and here in the center we have this spindle. What this spindle do? It moves the platter in clockwise or in anti-clockwise. Okay, it is just to move the um this platter in clockwise or anti-clockwise, right? And next, very important, this read write head. This read write head is, see, it can move forward or it can move backward. It can't move up and down. It only move forward or it move backward. See, if I'm pointing, if I'm moving this read write head towards this spindle, okay, so it will indicating the inner track. If it is moving outside this track, then it will be indicating the outer track. Okay, so this one is the arm assembly that is holding all the read and writes head. Okay, so this is very important to remember that this read and write head is responsible um, to fetch the data, right? It is responsible to fetch the data by moving forward or backward. If you want to fetch the data from the inner track, you can move for in the mm, forward direction. If you want to fetch the data from the outer track, then you can move it outside, like in the backward direction. Only this thing is there. Next one is the length of the track near the center is less than the length of the track from the farther from the center. That is obvious, because the structure is like that only. Next, you should remember these important terms. This is the GATE question came from this topic, that is magnetic disk, very important topic. So these terms can be asked in the paper, that what is this seek time, calculate the rotation time, latency, average assist time, given the some data. Now some number of sectors will be given, tracks will be given, and they have asked this term. So it is very important to understand these terms. First one is seek time. What is the seek time? The time taken by the read write head to reach the desired track from its current position. Wherever it is, the time taken to reach to the desired track from the current position, that is the seek time. What is this rotation time? Time taken for one full rotation. For one full rotation, whatever the time is taken, that is the rotation time. And simply the half of the rotation time is the rotational delay, or you can call it as rotational latency. That is the time taken by sector to come under the read write head. That is also half of the rotation time, right? Next one is data transfer time. What is the data transfer time? Time taken to transfer the required amount of data, right? Next one is average assist time, that is the seek time plus average rotational delay plus data transfer time plus controller time. If uh, if the controller time is not given in the question, that consider the controller time, then you simply take it as 0. Okay, if it is not given in the question, don't assume that we have to calculate it. It is not given, take it as negligible or take it as 0, right? I hope the terms are clear to you and the structure is also clear to you. So let's solve the GATE questions based on the topic magnetic disk. Okay, so how you can remember it, that what is the hierarchy? So first you have the platters. Okay, under platters you have the surface. Under the surface will be divided into the tracks. Further, tracks are divided into the sectors. Then sectors will be containing the data. Okay, so if you want to fetch the data, you have to go to sectors for fetching the data, because sectors are containing the data here, right? So transfer rate, yeah, there is another formula called as transfer rate, that will be given by number of heads multiplied by, okay, if number of heads are not given, number of surfaces are given, you can take it as that one, because the number of heads will be directly depending upon the platters or surfaces. Okay, because one read write head is needed for the, generally one read write head is needed for the one surface. So if surfaces are given, you take it as surfaces. If heads are given, take number of heads. Multiply by capacity of one track. Capacity of one track multiply by number of rotations in 1 second. Number of rotations in 1 second. Right. Another things are covered. Let's solve the GATE numericals. So this is GATE question. Okay, so to solve it, first you need to understand how we can calculate the different terms. Let me take one example. Let me take one example. Suppose consider a hard disk with four surfaces. Four surfaces are given to you. Okay. And 64 tracks per surface is given. Then 128 sectors per track is given. 256 bytes data per sector is given. These things are given. You have to ask that calculate the disk capacity. You have to calculate the disk capacity. Disk capacity will be calculated using all this. So what it will be? It will be number of surfaces multiply by number of tracks per surfaces, right? Multiply by number of sectors and data per sector. How much data per sector is containing, you have to multiply with that also to calculate the disk capacity. So number of surfaces will be 4, multiply by number of tracks will be 64. Then sectors, number of sectors are 128 per track, and then 256 bytes of data per sector. 256 bytes data per sector. So let me write in the powers of 2. 2 raised to power 2. 64 is 2 raised to power 6. 128 2 raised to power 7. Multiply by 2 raised to power 8, that is 256. So bytes. So how much data it is? 2 raised to power 23. So I can write it as 8 MB total disk capacity is there. So you might have remember that 1K is equal to 2 raised to power 10, 1 M equals to 2 raised to power 20, 1 G equals to 2 raised to power 30, and 1 terabyte equals to 2 raised to power 40. These terms should be clear to you while you are calculating the disk capacity. So you might okay. So next is we have GATE question. A hard disk system has the following parameters. Okay. Number of tracks is given to you 500, number of sectors per track 100, number of bytes per sector 500. The time taken by head to move from one track to adjacent track is 1 millisecond. Rotation speed is 600 revolutions per minute. What is the average time taken for transferring 250 bytes of data from the hard disk? The options are given. So let me write what is this average time taken. So, average time taken to transfer 250 bytes of data from disk can be calculated as average seek time plus average rotational delay. Okay, we have seen the formula in the last page, plus data transfer time. Here controller time is not mentioned, so I will not mentioning here also. I am taking it as negligible, 0. Okay. So to calculate the average time taken to transfer 250 bytes of data from the disk, I have to calculate the average seek time, average rotational delay, data transfer time. Three terms I should know, only then I will be able to answer this question. Okay. So let me find out the average seek time. Average seek time. How I can calculate it? So let me suppose the time taken to move from one track to adjacent track will be 1 millisecond, then to next track 2 millisecond, then next track 3 milliseconds, so on. How many how many tracks will be there? 500. So if I am starting from 0, suppose first to first में 0 time लगा, then adjacent में 1 लगा, then 2, then 3, so on to 4, 9 millisecond time it will take to reach the last track. So what will be the average seek time? It will be average seek time will be equals to summation of all this 0 plus 1 plus 2 plus so on to 499 divided by number of tracks, that is 500. Okay, so if you calculate it, it will comes out to be 249.5 milliseconds. Okay, so average seek time will be this much. First term we have find it out. Okay, now next is we have to find the average rotational delay. Okay, average rotational delay or latency you can say. So how it will be calculated? First let me see how many revolutions per minute is there given. Rotation speed is given as 600. So 600 rotations in per minute is 60 seconds. Okay, so how much one rotation will be there? One rotation will be 60 divided by 600 seconds. How much it will be? If you calculate it, it will be 0.1 second. So what will be the average rotational delay? It will be rotation, how many rotations we get? 0.1 divided by 2, because we have seen in the last page, see here rotational latency will be the half of the rotation time. So rotation time I have calculated as 0.1 second, so it will be simply divided by 2, so it will comes out to be 50 milliseconds. So average rotation delay will be equals to 50 milliseconds. What else we have to find out? Data transfer time. Data transfer time will be calculated as average data transfer time. Okay, it will be calculated as, in one rotation we can read data on one track, right? So let me calculate the transfer rate first. Okay, so transfer rate. Yeah. So transfer rate will be equals to, how many number of sectors are there? 100 multiply by number of tracks 500. So it will be, how much data it will contain? 50,000 data bytes of data will be there, right? And that this much data will be read in one rotation. Okay, so how much data will be read in 250 bytes? So it will be, so it will be calculated as, so yeah, so next one is the data transfer time. So it will be data transfer divided by the transfer rate. So how much data is transferred? 0.1 into 250, and transfer rate we have find it out 50,000, and when you calculate it, it will comes out to be 0.5 milliseconds. Okay, so this we have find it out, right? And what else we have find it out? So three things we have find it out: the transfer time 0.5 millisecond, then average seek time, and average rotational delay. So if we add all these terms, we'll be able to get the answer. Yes, we'll be able to get the answer. So here I am putting all the values here in the formula. Average seek time is 249.5 plus, what is your average rotational delay? 50 plus your transfer time 0.5, and when you add up all this, you will get 300 milliseconds. So 300 milliseconds the answer. Let me see the options. So D is the correct option, 300 milliseconds. I hope this is clear to you. Next question is, GATE 2015. So let me read the question for you. Consider a disk pack with a seek time of 4 milliseconds and 4 milliseconds and rotational speed of 10,000 rotations per minute. It has 6,600 sectors per track, and each sector can store 512 bytes of data. Consider a file stored in a disk. File contains 2000 sectors. Assume that every sector necessitates a seek, and the average rotational latency for accessing each sector is half of the time for one complete rotation. The total time in milliseconds needed to read the entire file we have to calculate. The options are given. Okay. So let me write. Here the seek time is given. What is the seek time? 4 milliseconds. Okay. Revolutions per minute. How many revolutions per minute are given? 10,000 rotation in 1 minute. That is 60 seconds. Right? So one rotation time will be equals to 60 divided by 10,000. It will comes out to be 6 millisecond. So this is the rotation time, or you can say that rotation speed. So rotational latency आ गई यहाँ से. Rotational latency we have calculated from here. How much it will be? Half of this, 6 by 2. It will be 3 milliseconds simply. Now, what is the time required? Time required to read file. What it will be? Time will be seek time plus rotational latency plus transfer time. Here also controller time is not mentioned, so I will not be taking it. So it is simply negligible. So what will be the transfer rate that we have calculated in the last question also? See, the similar type of questions are coming in the GATE. So if you practice it, you can able to get the answer, right? So it is very simple. If you know the formulas, you can able to solve it. So transfer rate will be bytes on track divided by rotation time or speed. Rotation speed, let me see. So it will be 600 multiplied by 512. 600 sectors, and how much data per sector is containing? 512. So simply I have multiplied 600 by 512 and divided by what is the rotational speed? 6 milliseconds. Okay, 6 millisecond and this much of bytes of data. So it comes out to be 100. So it will be 51200 bytes per millisecond. Transfer rate we got. So transfer rate we got, we can able to find the transfer time from here. Transfer time. So it will be data transferred divided by the transfer rate, right? What it will be? Data transferred will be 2000 number of sectors multiply by, let me see if I am correct. Yeah, a file is containing 2000 sectors. 2000 multiplied by 512, that is data per sector, and divided by transfer rate we have find it out. 51200 will get cancelled with this. This comes out to be 20 milliseconds, right? Now each sector requires seek time and rotational latency. It is given that each sector requires seek time and rotational latency. Okay, so I simply add both. Seek time is 4. Okay, it is given that seek time initially I told you plus rotational latency, it comes out to be 3. 6 divided by 2 is 3, so it will be 7 milliseconds. So 2000 sectors will take 2000 multiplied by 7 milliseconds, so it will be 7 to the 14,000 millisecond it will take. So how much total time it will take? Total time it will take as 14,000 plus this transfer time, that is 20. So it will comes out to be 14020 millisecond. Okay, this is the, I hope the numerical is clear to you. You can practice many questions on this topic so that you can get the idea, and with practice you will be able to get the correct answer. Okay, so this is easy topic. So if you have any doubts in this topic, you can contact me. The email ID is given below, and you can comment below also. So that's all for the today's lecture. Thank you.